So today what we'll be looking at is ETL primarily via Python, right? So I think we've had quite a few sessions which had to do with ETL. The previous KKSS session was one where Anushree actually compared quite a few softwares which let you do that, right? So what we'll be doing today is looking at how Python can be used for ETL. That's one. Why use Python? What are the different important modules when it comes to Python in the ETL space? A few examples, do's and don'ts when it comes to scripting for ETL scripting in Python, right? And then how you can deploy these Python scripts so that they run automatically, or what are the different ways you can do that. So and finally, I'll kind of walk you through one example for one of our clients where we deployed a Python script for extracting information from APIs and then storing it as CSV files on a virtual machine, right? So let's get started with the first bit. Why Python, right? So all of us kind of understand that one, the cost aspect of it, right? So we looked at the prices that Anushree shared with us in the previous session. They are extremely large amounts of money, exorbitant amounts of money, like $10,000, $20,000 per year. So these could work for a lot of enterprises, but not necessarily clients or smaller clients or smaller startups, for example. They might not have the capacity to spend money at that scale, right? Even stuff like SSIS, even though it's free, connectors there cost a couple $1,000s at least. So connectors are stuff that you need to access certain data sources or use certain features, for example, which aren't readily available. So cost is the one of the most important aspects why we choose Python over the other pre-made softwares. Next is the simplicity and flexibility, right? So Python, many of us are aware of the language. It isn't too complicated when compared to the other languages. It is also quite flexible, right? So one example of flexibility that I can think of is, so I was trying to rename a particular file after extracting it from an API in Talent recently. Like, there's no easy way to do it. The roundabout way to do it with the existing tasks was to create a copy and name that copy differently and delete the older file. So this sounds like a simple enough task, but for all these specific cases, right, there's no easy way to do it. If what you're doing doesn't fall in the framework of things that people think of, like when they create the tool, it is very difficult to make those changes because it doesn't fall in any of those particular components that they've created. It might be very simple, a very small change or a difference to the stuff that the component does. But if it's not the exact same thing, you can't do it there. But here you have that flexibility. You can make those modifications, adding a couple of lines of code, and it does that job for you, right? That's another advantage that Python has. Then when it comes to integration capabilities, right, I briefly talked about it when I talked about the different connectors. So a lot of these, the cheaper softwares don't allow you to integrate with a lot of different data sources. They either have limitations or they want you to buy stuff on top of that to get access to that. But Python, through various modules and libraries, you're able to connect to almost all the possible types of data sources that you can think of. So that integration capability that Python has is unparalleled. The libraries, right? So a lot of us have heard about pandas and NumPy, but there are lots of other libraries which are specific and have been made around built for ETL, right? So you can easily use these packages to easily do tasks like, say, transformation or connecting to an API or monitoring or auditing the quality of data. So there are lots of different packages that people have built and are freely available online that we can use uh, to make our lives easier. You don't have to build every single function or every single capability because people have already done it and shared it with you, right? That's another benefit. Then the user community, this a lot of people would definitely know, and it makes a huge difference, right? Whenever there's a small issue that we are facing and we're not sure what to do, we search online, right? And the more the engagement, the more the probability you get solutions for your answer. So recently, when Talent was taken down, they took down their community as well, like the free the community which was there before. So right now, all those questions, even though you can find the questions, if you go in, the page is missing. So without that community support, the tool almost becomes obsolete. Even if it works fine, without that community bit of it, right? Or professional support of sorts, um, the tool is very difficult to use. Python has this advantage that it's followed by a lot of people, and it has a very active user base. So that helps solving a lot of problems that you face, and it's helpful in that way. Scalability. So we'll talk about this in the deployment bit that I've planned, but Python scripts can be scaled like really easily, and it can be done multiple ways. And some stuff like probably the softwares which are based on local premises like SSIS cannot scale in that fashion. The cloud softwares can, but again, they have costs associated with that as well. So I'll talk about this in detail towards the end, right? Any questions until now? Or can
Yeah,
I?
a quick question. So, see, apart from Talent, which used to be free for the basic version, right?
Mhm.
So, is Python the only other option that is credible, or are there other
SSIS,
options too?
SSIS is free, but
Is also
if
free.
if you need like certain more advanced capabilities, um, you have to buy third-party connectors or third-party packages which uh, have to be added on top of it.
Right.
So
Yeah.
yeah, but SSIS for most part is free.
And also for Microsoft only, right? That's another issue.
Yeah, you'll have to. I'm not 100% sure about that, but I think that is the case. You have to install it on a Windows system, I suppose.
Okay, okay, got it. Okay, cool. Great.
All right, let me go to the next part. So there are quite a few talent libraries or packages or modules, whatever you call them, that are very important when it comes to ETL. So these are some of the packages I found were most useful and most commonly used. Pandas and NumPy, I think almost all of us have heard. It helps dealing with any kind of structured data. You can convert CSV files into data frames or JSONs into data frames, and then do a lot of data pre-processing. You can clean stuff up. You can rename columns. You can do summations, for example, or multiply stuff, filter stuff off. So all that capability you get in Pandas and NumPy. So requests is one package where you can use this for API stuff, right? So if you have a API data source, like I'll be showing you one example. What you can do is you can import this requests package, and it lets you do HTTP requests. You can do post requests or get requests with the API credentials. If you have the client ID and the client secret, you can pass that through and get that result back, and then convert it into, say, from a JSON into a data frame and do your computation or processing on top of it. So requests in that aspect, anything to do with APIs, this does a really good job of helping you connect to stuff. Then anything to do with SQL, right? SQL Alchemy is really helpful. So this helps you run queries, connect to SQL engines. Like if you have a SQL data source and you want to connect to that, you can use this. And on top of that, write a query and use that query as your data set to process or to report on, right? So that is one of the important benefits of SQL Alchemy. Then Bonobo is I've not used it personally myself, but a lot of people have vouched for this, and they use this to set up ETL pipelines. So this essentially you can set up different processes in pre-processing and then create one pipeline, and you can just run that pipeline and it does all the work. So it's like an ETL framework of sorts, and it has the ability to connect to various data sources. That's one added benefit, and a lot of people use this for ETL work. PySpark, this is for big data. So it's in Python API for Apache Spark. So this is distributed computing. So when you have lots of data, big data situations, you can use this. Bubbles is also one that I've not used, but I've heard of a lot. So this specifically is I've heard that it's really good for data integration, cleansing, and monitoring as well. So monitoring and auditing the data qualities. I've heard it has a lot of modules which help track those kind of things. So that's one more package that is very relevant to ETL. Any questions on any of these packages? Okay, so let me go to the next bit. So next, this is a very simple example. So I just wanted to show you. So I wanted to show you an example, then show you certain do's and don'ts and how this example kind of follows that. So here, what we're doing is we're creating different modules of sorts, right? So we're creating different functions, and then using that function in one main function, and you just run that, and it does all those things. And the main advantage of doing this is that you can reuse these modules in different situations. So what we are doing here is we are reading a CSV file, right? Then doing a small transformation, like we're multiplying two columns and creating a new column, loading it, right? And what this main function does is essentially you're telling what that input file is. Here it was a variable, and then you're doing each one of those steps. So you're calling each one of those functions right here, and you're telling the process has been completed. So this is a very simple example, and what I'll do here is like I'll talk about certain do's and don'ts, and you'll see that why this is a good example when we talk about that. So when it comes to do's, right? So initially when we start off in projects, like you might have one CSV file, right? So what you'll do is you'll do all the processing. You'll load the whole file and you'll do all the processing. So what happens is as data is being appended and the data source becomes larger and larger, this will significantly decrease the performance. So almost all packages have this thing called chunk size. So you can define how many rows you read at one time and do the processing. So this helps keeping the whole thing smooth. If there's an issue as well, you've done say 1,000, like 10,000 or 20,000 rows, and you can restart from that point. So it helps both in the performance aspect and debugging aspect as well. So that's one really important thing that has to be done. Handling errors is another thing. So a lot of people don't do this. So what I mean by handling errors is, so for example, we know that a client for a function has to input, say, a positive number. They by mistake add like type in a text or a negative number, right? So what will happen? Nothing will happen, right? Because you've created the function or the whole script assuming it would be a number. The client has done a mistake, but he doesn't know what he has done. He gets no feedback, right? So you'll know a list of errors that are probable or plausible to happen in the situation, right? So you create situations or contingencies for them. So you say if this happens, you do this. So a lot of people would have heard about this, like try and catch errors. Like you catch an error and you send back a feedback of sorts to the client by using the command prompt, like essentially printing stuff on top of the command prompt or sending them emails or whatever. right? So handling errors is very important, because a lot of the times your function, when an error happens, it won't be clear enough. You might be able to debug it, but when it's running in a production environment, the client is definitely not going to know what has happened. So that is really important. Modularizing is something that we just saw, right? So it's very important that you create different modules and then reuse them, because one, it's a lot cleaner, right? People will be able to understand what different functions do, and you can comment on top of them, and it's easier to understand. That's one thing. And it's very helpful when you're creating a lot of different things, right? You can use the same chunk in 10 different places, or same module in 10 different places, and overall reduce the amount of code you have to write and the amount of time you have to spend. So it's really important that you modularize, right? Next, document and test code, right? So I think this is very self-explanatory. Documenting it either with a separate document or adding readable comments. Like, a lot of people add comments, but they are not easily understandable. You might be able to understand it. You might be you're familiar with the code, so that is like something inherent. But you have to make sure that a person who is starting at zero is also able to catch up. So that is really important. Optimizing performance. So this happens. So what we do is, because it runs fine, we just leave it at that, right? In the initial situation, it would have taken a minute. So like, what's the difference between a minute and say 10 seconds, right? It's not too much. But when stuff scales, this performance will also scale. Like, it will be exponentially poorer in performance, right? So it's important that you follow best practices and try to optimize performance in the very beginning, so that when everything scales, the performance also scales accordingly. Using version control is also something that people easily forget. So keeping track of different versions, the changes that have been made to different versions is also very important. Next, I'll be going into don'ts. Anything anyone wants to discuss before that? Okay. So a few of the don'ts, right? So the first one is very important. Don't hard code credentials. So I'll be showing you an example with our client as well. So you will have a lot of sensitive data when you're creating ETL scripts, right? You have the essentially the password and key for the client's whole data warehouse or data source, right? So if you just add it in the script, right? Anyone who has the script, a lot of people will have your script. Just so you know, you will be publishing it. A lot of analysts will have it. A lot of developers will have it. People in posterity will definitely have it, right? So what happens is, if you hard code the credentials in the script just as is, anyone can use that and do whatever they want, right? So it's very important you don't do that. So there's something called environment variables, which a lot of people use to bypass this. So it is essentially creating a variable in the script and then having those variables assigned values in a different place. Usually on a cloud system, you can you'll have something called environment variables in Windows. So you can add those passwords in a different spot with security. And people who have access to your script won't have access to those files, because not those files, but those credentials, because it's in a different spot and you have control over who sees it and who doesn't see it. So that's very, very important. And ignoring data quality is also something that we should never do. This reinventing the wheel thing is something that I thought was very interesting. What happens is, a lot of people, when they start out with stuff, right, they want to like use their knowledge of all the stuff that they learned in that very same Python script or Python package or anything like that. So they want to do every single thing using the very basic packages, like very basic functions or something like that. But right now, a lot of developers have created a lot of different packages which already do something that you will do with 20, 30 lines of code in one line. So you don't have to code everything every single time when they're readily available. They've been already time tested and used by a lot of developers. You use those ready-made stuff when it makes sense. You don't have to reinvent the same thing again and again just because you have the capability to do it, right? So the performance bit, I think we have the do and the don't. It comes there. They are related, right? So I won't get into that. Don't rely on manual processes, right? So you could have created the script. So this has a lot of implications. One, when deploying stuff, you don't want to make the client do certain things for the process to happen. So this could be stuff like they have to maintain something to for everything to happen really well, or they have to run something, or they have to keep their system on. So it couldn't be any manual thing that you set up. The client may be the most diligent person, or he might have the best team in the whole world, but manual processes are not going to work. They will stop working at some point, and we should never leave stuff, at least stuff that we have control over, to be something which is like passed on to a different person and expect them to follow it in any frequency, right? Data lineage is also very important. So most of the times we have lots of different data sources, right? So all these data sources, we then do quite a bit of transformation, and we create one kind of data set or a table, for example, but we don't know where what comes from, when it came, what we did on top of it. So that data lineage is also something that a lot of people seem to ignore. So this is especially important if your data is error prone, right? If you don't do this properly, wherever there are lots of errors, right? Like not because the script you've written is erroneous or something like that, but because the data is of that nature. Like you miss certain data certain days, like some streaming service somewhere has gone down, or some warehouse, there was some kind of glitch. So whenever this happens, like for you to debug stuff, if you don't have data lineage, you're going to be scratching your head. You have to go through the whole stored procedure or script to find out where what came from, what you did on top of it. So that is also something that shouldn't be ignored. So these were broadly the do's and don'ts. The last bit I'll be doing is the deployment part. So Python scripts can be deployed and run in a lot of different ways. So the first one is like a normal execution. So you create a script, you create a batch file from it, a Windows batch file, for example. You double click the batch file and it runs. So that's local execution. The same batch file, if you schedule stuff using the task scheduler in Windows or cron in Unix, so it is going to run automatically. What it's going to do is it is going to double click that batch file instead of you at that given point of time. So that is schedule jobs using task scheduler in Windows or cron, right? So that's one more way you can deploy. Using Docker. So Docker essentially is like a platform. Okay, how do I put this? So it creates containers which can be run on different kinds of platforms. So it is like platform. I'm not sure what the word is, but it doesn't depend on what platform you're running. It creates an environment for that particular code to be run on any different any platform, say a Linux platform, or next day the Windows, or you're doing a distributed thing. You can use Docker containers wherever. It makes sure that the code transfers to different environments. So that so Docker is used for that. So you can do that. Serverless computing. This is something that Sinad actually covered in one of our previous sessions. So he talked about Azure functions to run Python scripts, right? So you can use AWS Lambda or Google Cloud Functions as well. So the advantage here is that you don't have to create a server, maintain a server. You just pay for amount of time or amount of requests you do. So it reduces a lot of maintenance. So that is, and it scales really, really well. So that is one advantage of serverless computing. Then batch processing. So this is mainly for big data situations. So Apache Spark and Flink. This is used for distributed computing. So whenever you have large amounts of data and you're batch processing them, you can use these frameworks to deploy your Python script. We also have ETL tools. So the last one and the second one from the last are very similar. So one is managed ETL platform. The other is a normal ETL platform. This is on the cloud, and this is so here also you can use those scripting components, right? So all of the tools, especially the ETL tools, have this scripting component where you can essentially use the same Python script and deploy stuff. So you can do that either on these tools or managed platforms like Glue or Data Factory to run these and deploy these scripts. So this is also a way you can essentially process or deploy different packages. So that is all I had on the Python ETL demo.